Hello and welcome to HTM Hackers Hangout. It's March 3rd. I'm Matt Taylor, and thanks you for watching. We're going to talk today about a few things. Sorry, we were just having this deep conversation about temporal memory, and I'm trying to get it out of my head. So at the end of this episode, at the end of this, Marcus and I think are going to continue having this conversation about temporal memory predictions. Anyway, let's talk about what's going on in the community and stuff. So it's been a month. So a few things I wanted to mention, and then, like as always, open it up to anybody else who wants to talk about anything or ask questions or have conversations. So first of all, we've got a lot of events happening where we're going to be represented, or Numenta. Let me share my screen. Let me pick which screen to share. This is so well planned out. All right, so that's what we're doing now. So our events coming up, Jeff Hawkins, our founder, is going to be talking at the NICE workshop this year in March, soon, very soon. And he'll be at Cornell, and that's this coming Tuesday, or next Tuesday? I don't know, March 7th. Christy, our director of marketing, will be at Earth Pixels in Milpitas. And I'm giving the same talk at these two conferences, Open Data Science Conference East in Boston, May 3rd, and at the O'Reilly AI Conference in New York City. And I'm giving a talk called Towards Strong AI. So being a bit controversial in the topic, but that's fine. That's kind of what I wanted. Scott just did a webinar, and I sat in on that, and that was nice. And we were just at Cosign. We had several people at Cosign. But so that's for upcoming events. There's also an online.
I got one ad.
Yeah, what?
Yeah, it just came in yesterday officially. I'll be speaking at the IEEE Digital Automation Conference in Austin toward the end of June.
Excellent. That's a good snag. So we'll add that to the website as soon as we get details. Just send it to Christy, and she or I will do it.
Sure thing.
Okay, next up on our list. Oh, I was going to say there's one more. It's AI with the Best, ai.withthebest.com, I think. It's an online conference. It's cheap, and people liked it last time, so I'm doing it again. Jeff Hinton is doing a talk there, and the guy whose name I can never pronounce. Sorry, I'm not even going to try. So the next
person, or
yes, it starts with a Y, and
Joshua Bengio.
Yes.
Yes. Yeah, I saw him speak a couple times this past weekend at Cosign. He has a very musical voice. It's fun to listen to him talk.
Awesome. So if you register for AI with the Best, you'll get to watch those live and ask questions at the ends of the talk. So, okay, so the continuing educational work, I'm still working on an HTM school videos, and this is probably going to continue evolving. So Jeff has taken an interest now, and he's talking to me about maybe doing some other things in that style regarding some of newer theory. So at some point you might see that. I don't know, not making promises. We'll see. I also am going to be putting out this is the worst job, honestly, NuPick compilation guides. Not that I'm complaining, but this is the most annoying thing to do. But it needs to be done. So I start up VMs, I start a fresh Ubuntu, whatever is the latest 16, and install NuPick from source code from scratch, and at least walk through it. And this gives me a chance to exercise the whole process. So it's beneficial. It just sucks because it just takes a lot of waiting and typing the wrong commands. And anyway, I'm going to try to do it for Windows too, as well as Mac OS. Other than that, NuPick stuff, I'm working on API docs, and they're a lot better. Austin, don't say anything. I'm working on API docs. This is the way it should have been done before. But these are so much better than the last ones, and we've got some really nice linking and formatting. The parameters all look nice, code styles. But the thing is that there's a lot of changes that need to get made to doc strings to get this working. I'm also working on NuPick Core in the same style. It's going to be the same Sphinx style because we found a tool. Scott told me about a tool called Breathe that you can convert Doxygen XML output and have Sphinx process it. which is wonderful. So we could potentially get these in a very similar format and look and feel, which will be really great. So I'm looking forward to that. That's all I'm working on right now. Yeah, I wanted to mention this. So we haven't got a lot of community contributions. I don't think it's a big deal. And I think it's because we've been focusing all our efforts on research, and I think people are kind of waiting to see what happens from that. And that makes sense, right? There's a lot of other HTM. I don't need to present anymore. So there's a lot of other HTM implementations out there that are doing things in slightly different ways and experimenting and trying cool stuff. And I think that's awesome. And I think that's where a lot of the efforts are going as far as programmers focusing their attention on HTM. There's a certain group of people that want to try and apply it and are trying to use NewPick and apply it to their data. That's awesome. I still think there's lots of potential there. But the people who I think are most interested in contributing back, especially to the theory, are doing this work. And I think there's more people interested in contributing back to the theory than contributing back to specifically the NewPick or HTM Java code. But that's okay. And I think when we come out with new stuff and it goes in, there's probably going to be an uptick in interest, an uptick in contributions. But at this point, I don't see a big problem with this. Because people are still engaged and are still interested, and that's what I'm most concerned about. That's it. That's all I got. So, I don't think anybody's on chat. There's some people watching, so I think if you type in to chat, you can ask a question. But otherwise, do you like I bought this Rembrandt at an estate sale this morning and for $10. Pretty good. But yeah, any other things you want to talk about? Let's see, we've got somebody online here, Daniel. Nice to see you. I can't hear you though, but if you want to, you might want to turn your mic on if you want to chat. If you're just watching, that's fine. How about you guys, Marcus and Austin? Any updates from you? What are you working on?
Research, connecting cells to other cells, and activating cells and having them represent things.
Very nice. On the note of research, I forgot to mention this, but Jeff and I are planning on having a chat when I'm in the office in about a week and a half. And I want to talk to him some things about new theory, especially now that I feel like I have a better understanding of current theory, and explore some of his thoughts about what's happening in research right now and the direction that it's going, and how it relates to current implementations. I know there's some confusion about that. So I started a thread on HTM forum about this, and people are asking some questions that I'm going to try and curate and turn into a conversation with Jeff about these things and kind of mix it into some things that I want to talk to him about as well. That should be fun. And I know it's not, an office hour style. You can't join in and live ask questions, but we're not going to give up doing that. We'll still do that. But I usually kind of wait for people to start asking for that before I do it, because it sucks to start one and there's only 3 people there. So it's more fun when there's more engagement, more people. So when you guys want to do that, just let us know. So I guess that's all we got. So do you want to continue talking about temporal memory? Sure. All right. So I was trying to explain, okay, when cells are predictive, this is really what I want to do is identify how predictions occur. Because let's say, identify from one spatial input, all the sequences that are associated with that spatial input. That was my initial point. It was thing I was trying to do, and I realized it was impossible to do. Would you agree with that, Marcus? So what, representing all sequences associated with a single spatial input? So yes. I mean, because when you burst that, you are essentially doing that. When you burst a spatial input, all the cells that are active are like one context of that input. Now, if you're talking about no, I understand that. That's during learning. I'm talking about retrieval. I think it's different. So I want, if given one spatial pattern and a system that's already learned, give it one spatial pattern, and I want from the state I can retrieve from that one, the operations I can do with that spatial pattern. How can I identify individual sequences? And I don't think it's possible. You have to have
I mean,
you have to have at least another time step to start nailing down what sequences you're in. I think there may be a way
with every new time step. Yeah, with every new time step, you're going to get more information, so you'll narrow it down. But with
that,
just
that
a single
operation
input,
right there that you're talking about, that operation of as you get a new time step, narrowing down, filtering out the potential sequences that this is, does that actually happen in our code? Or is it just a happy side effect of whatever structure we've implemented?
Yeah, I mean, because the initial input happens, you burst, and then now you predict basically a union of like a big union of predicted cells. Then a new input comes in.
Yeah.
Now it's generally not going to burst. It will activate a smaller set of cells. For example, that still might be a union. You can bring up the examples of ABCD and XBCY.
Mm-hmm.
If your first input is B, if you burst B, then predictions are still then your predictions are both types of C. So when a C comes in at that point, way, but not all the way.
Yeah.
But D comes in.
Let me step back here. I know where you're going, but my ultimate goal here is to try to identify somehow and extract a definition of each sequence given like 4 inputs, or given n inputs in a row. I want a way to extract and identify in a way every sequence that could be a part of. So I'm thinking there would be lists of time step, but not time steps. They're just things that it's a linked list, right?
Mm-hmm.
And each one is a spatial state of the whole system. Not a spatial state, sorry. It's just the active cells. And that could identify one sequence. And I want to get that definition given, X number of spatial inputs in a row. Is that possible?
You would have to have something. Basically, you have these you must have like labeled sequences, and you just from the outside you have to check. You'd have to compare it
because of the union, because you'd still have this union that you'd have to try and I don't know.
Well, the thing is, like, if you see, so let's say you've learned 5 different sequences that start with ABC. Let's say you have ABC, XY, ABC, DH, and so you have a few of these.
Yeah.
At the point where you hit C, you don't have a union. At the point where you hit C, you have it narrowed down to basically one sequence, and then it diverges after that. So the point is, these representations. Okay, these representations aren't really specific to a full sequence. They're specific to what led up to this point.
Okay, so that brings me to another question. I understand that, and thank you for that explanation. That makes sense. My next point is, I don't ever, like, bursting is obviously the beginning of a sequence or the beginning of a node in a branch of another sequence, where a sequence splits. But there is no ending cap. There's never an ending cap unless you manually cut it, right?
Right.
How does that work? Because there's got to be a way that you can close sequences, or else, I mean, it just doesn't make sense to have all of these open sequences. I mean, you identify and classify temporal patterns, and I think that's the classification part we're talking about, right? As ending the sequences.
Right. So generally, a lot of experiments end up using a reset signal, and that's what that's for. If somehow you can mark that, all right, now I'm at the beginning of something new, or that was the end of something, then you do a reset. And the assumption is just that, like, that at some point we'll find a biological equivalent for resets. I mean, when you shift your attention somewhere else, just call that a reset. There are just so many possibilities for where the equivalent of a reset could happen.
Okay. Wow. Okay. So that's really interesting. For some reason, I thought it didn't take attention for this to happen, or at least there wasn't. I guess
it takes
this is a
some
part of some
external
feedback,
resets.
right?
What do you say?
This is probably a part of the role of feedback, right? Because some of these this is like, closed statement commands are going to be coming from something that's understanding this better, or at a more abstract level.
Yeah.
So I assume it would be part of the feedback would be doing this.
Yeah, the temporal memory without reset signals grows forever. It keeps learning stuff in higher and higher contexts, higher and higher order contexts.
This is a really important point that I'm surprised I didn't grasp up until now. So I think, yeah, this would be good to talk about in an HTM School episode. Because the resets have always bothered me, and I never really knew why, but it makes sense now. Thanks.
Yeah. And really, I say it grows forever, but theoretically, or rather, part of that is because of how it's currently implemented to not really have very good cleanup.
Yeah.
It wouldn't necessarily have to grow forever. It could, like, after a segment hasn't proved useful after a certain amount of time, it prunes it. It could do that kind of thing. So that could be a solution to the everlasting growth. It's not fundamentally flawed, but it's, but yes, it will keep learning higher and higher order context.
Yeah, I'm just thinking something like a memory that could really remember songs which have so many hierarchical structures, with patterns within patterns, and it just feels like that sort of thing doesn't necessarily take your attention. It's just part of the structure of the data, right? It's part of the structure of the world. It's not, you don't necessarily have to attend to noticing that, it just is.
Right. A couple times you've brought up this hierarchical sequences, but a single temporal memory doesn't really handle that. I mean, You're already using the word hierarchy. They're kind of basically that.
I see hierarchies everywhere, so this could just be part of that. So I see what you're saying, because you can't really nest sequences within sequences if it's not linked like that, because it's not. I can understand that now I think about it. It's more like a web, I guess, or just a huge tree.
Yeah, because if you have a subsequence that's shared between sequences, what eventually happens is every element in that subsequence gets a totally different SDR.
Oh,
totally different SDR from, so this shared subsequence in many ways, not only is it not useful, shared subsequences actually make learning harder. Like it takes a while to learn the shared subsequences, because you have to come up with like a new context for each one, and you do all this bursting as you learn it. Yeah, I would say the idea of like this kind of a compositional world, compositional sequences where things can be embedded in other things is just not. It just doesn't happen with just a single temporal memory. That requires something more experimental.
So it's sort of funny though, because we're talking about hierarchical structures in data, like songs or whatever, and in order for our brains at least to understand this, it does seem like a hierarchical structure within the brain has to exist, because that's what's going to identify those patterns within patterns, right? It's interesting. Stuff is pretty interesting.
Or hierarchy in some sense has to exist. The question of whether, I mean, I'm just talking here. This isn't like Numenta internals or anything, but like the hierarchy might be embedded within a layer. Maybe layer 2 has like,
oh sure, yeah,
things pooling things which are pulling things. Maybe it has a mini hierarchy inside of it.
I mean, we do that today in experiments, right?
Yeah, basically. So yeah, it might not be the case that like the hierarchical nature of the cortex is solving that problem. It might be solving a different problem. Who knows? I'm just talking.
No, sure, that's fine. This is not like official Numenta business. This is what they let me do for fun. Okay, I guess I should close this off. Thanks for watching if you made it this far. There's 11 people watching us have that conversation. Thanks. All right, we'll see you guys later. Ask questions on the forum. Take care.
Cool. See ya.